Welcome to Chem Help ASAP. Let's see a few sample IR spectra so we can get comfortable identifying functional groups. Before we actually look at spectra, we need to cover a few ideas. First, you do need to know which functional groups show up where. The previous two videos in this playlist cover the most common, most relevant IR signals. You need to know these signals before you interpret spectra. Second, the position of signals should be taken with some flexibility. Signals should show up within about 10 wave numbers of their reported value, but you need an open mind. Roll with it. Third, always keep in mind that the absence of signals is also valuable information. If you do not have a peak at about 2200 wave numbers, then you know that you don't have a nitrile. So it's not just what you see, but also what you don't see. Finally, we cannot interpret all the peaks, so don't try. Let's see some spectra. All these spectra were pulled from the spectral database for organic compounds. There is a link to the site in the video description. First spectrum. First note, look at the x-axis. It runs from about 4,000 down to 400 wave numbers. We could ignore anything less than 1,000, as these signals are typically uninterpretable. Second note, I have included a peak listing on the screen so we can be certain of where these peaks are located. The first big absorbance I see is right here. According to the table, this absorbance is at 3338 or 3328, and the intensity goes all the way down to 9% transmission. That's 91% absorbance. That is a strong peak, and this peak is broad. That is a classic alcohol OH stretch. If you have an alcohol, you often have a CO stretch. We should be down between 1200 and 1000 wave numbers. That signal is likely here. That's 1066 wave numbers according to the table. Great, so there is a CO stretch. Just about all molecules have CH stretches here around 3000. Most of these peaks are just below 3000, which indicates sp3 CH bonds. There is one blip past 3000. The table says 3026. That signal is a sign of an sp2 CH bond. So our molecule likely has a double bond. Is that double bond just a regular CC double bond or an aromatic ring? If we look at this prominent peak right here, it is at 1650. According to the table, that is really close to a value of 1640 for an alkene. Aromatic rings are normally at 1600, so this looks like an alkene. What is the structure of this molecule? It is cyclohex-2-enol. The main functional groups are the alcohol and alkene, and we could identify both of them in the IR spectrum. Here is another compound. Looks like we do not have an alcohol here. What do we have? Any large peak from 17 to 1800 is almost certainly a carbonyl. This big signal is at 1765 wave numbers. This is a carbonyl. It is probably an ester, which I would typically look for at 1740. If it is an ester, then we should see a CO stretch in the 1200 to 1000 range. We have two signals down here. So let's see, 1216 and 1194. Okay, so these look like the CO stretches of an ester, so it does look like an ester. What else? There isn't much in the CH region, but what is here is mostly beyond 3000 wave numbers. So this could be sp2ch is from an alkene or aromatic ring. If alkene, we might see a peak at 1640-ish. If an aromatic ring, we'd expect a signal about 1600. What do we have? This absorbance at 1594. That is an aromatic ring. Anything else? We have these strong peaks at 1493 and 1371, but these aren't in an interpretable region, and we should ignore them. Okay, we have an ester and an aromatic ring. What is the structure? It is this molecule, which is indeed an aromatic ring and an ester. Perfect. That was a quick walkthrough of 2 IR spectra of simple, representative organic compounds. Please ask questions if you have any in the comments section below the video. Take care.